Assalamu alaikum viewers, hoping you all guys fine. We are here with a new topic, torque or moment of force. So what is torque? Torque is the turning effect of a force produced in a body about a fixed point, and that fixed point around which the body rotates or turns around is called pivot. Another definition is the product of magnitude of force and the perpendicular distance from axis of rotation to the line of action of force is called torque, and the perpendicular distance from axis of rotation to the line of action of force is called moment arm. So we shortly define it, the product of magnitude of force and moment arm. Mathematically it can be written as tau is equal to L into F, where tau is the symbol of torque, which is the Greek alphabet, tau, and L is the momentum and F is applied force. Thirdly, we can define torque as it is the cross product of force and position vector from pivot to the point of application of force. This position vector is from pivot to the point of application of force. So in mathematical form, cross product of force and torque can be written as tau is equal to R cross F, and when we expand it, it is Rf sine of theta into n unit vector, where Rf sine of theta is the magnitude of torque and n is the unit vector which shows the direction of torque. We will discuss a little later the direction of the torque. Now, what about the unit of torque? In System International, unit of torque is Newton meter. Newton for force and meter for moment arm. Dimension of torque is the dimension of force, which is mLt inverse square, and dimension of R, which is L. And L into L will be L square. So mL square T inverse square is the dimension of torque. From here we come to know that torque is a vector quantity. So torque is a vector quantity having a proper direction. Examples of torque are many in daily life. One is tightening or loosening of a nut with spanner. A seesaw rotates on and off the ground due to torque imbalance. And opening and closing of door is easy with the help of this phenomena, torque. Now we talk about direction of torque, and the direction of torque is determined by right hand rule. And right hand rule is very simple. Curl the fingers of your right hand in the direction of rotation. Curl the fingers of right hand in the direction of rotation. The erect thumb will point the direction of torque. So simply curl fingers of right hand in the direction of rotation. The erect thumb then will point the direction of torque. Now come to the important point, that in linear cases motion is caused by force. If force is small, motion is small, and if force is large, motion or velocity is large. And this is well established by the Newton's second law, which is acceleration is directly proportional to the applied force. Then why do we need to introduce torque? Question arises. Then why do we need to introduce the new term torque? So remember guys, unlike linear motions, in rotational motions that include spin motions and orbital motions, in addition to force, another factor is also important for describing motions, and that factor is the distance of point of application of force from the pivot point or axis of rotation. It means in rotational motions, two factors are important to describe motions. One is the force and the other is the perpendicular distance between line of action of force and the pivot or axis of rotation. Look at the example. When we try to open or close tight this nut by applying the force directly like this, we face difficulty. It is not easy to open or tight the nut directly by applying force by your hand on this nut. But when we use a spanner like this to open or tight the nut and apply our force on this end, we easily open or tight this knot. And what is the difference? Difference is that in this case we apply the force very near to the pivot point. The distance from the point of application of force to the pivot is very small, so we have to apply a large force to open or close or tight the nut. And here we can see that point of application of force is away from the pivot point and by a distance of r, and we apply force here. Pivot point is here, here is the nut, and we apply force here to open or close this nut, and with a small force we can open it or tight it. So in order to rotate this nut, in order to cause rotational motions other than force, this factor is also important, which is the distance from the point of application of force to the pivot point. And we see it deeply, we see that it is the perpendicular distance between line of action of force and the pivot point. So we see it further in details and consider its vector form. Let us consider the general case in which force is not perpendicular, but force applies at an angle of theta with the position vector from pivot point to the point of application of force. This is the angle between force and r. Resolving force into two components, rectangular components, this is the f sine of theta, which is perpendicular to the moment arm or this position vector like this, and f cos of theta is along the r. F cos of theta, when we apply f cos of theta, it will not contribute to rotate. Rotation means to tight or open the nut. But f sine of theta is the effective component here to open or close this nut. So in order to rotate, in order to open or close the nut, in order to open or tight the nut, in order to cause rotational motion, the effective component of force is f sine of theta. And when we consider this, torque is described here by moment arm, which is the distance r, and magnitude of perpendicular component of force, which is given by r into f sine of theta. Shortly, we can write it as. Another way to describe this phenomena is that other than force, you resolve r into rectangular components, and when we resolve r, if this angle is theta, opposite angle, this one is also theta, or and this is r cos of theta, horizontal component, and this is r sine of theta, which acts here as moment arm. This is the line of action of force, and we can see that r cos of theta is along the force, and this will not contribute in causing rotation there. Only factor which is important for producing torque is this perpendicular distance from the line of action of force to the pivot point, which is r sine of theta, and this is called moment arm here. And when we write equation of torque, in this case, this comes out to be perpendicular component of position vector r into magnitude of force. So torque is r sine of theta into f. In both of these equations, we can see that r is the magnitude of one vector, f is the magnitude of other vector, and sine theta comes here, and theta is the angle between r and f. when this situation is there, so we can write torque in terms of vector form, which we know A cross B is equal to AB sine of theta, like these vectors. So torque is can be written in terms of vector form. Tau is equal to cross product of R and force, where R is like the position vector from pivot point to the point of application of force. So tau is Rf sine of theta into N. We have discussed that this is the magnitude of torque and this is the direction, and direction is given by the right hand rule, as we have discussed earlier. So if we discuss about the summary of the torque, what are the main factors on which torque depends? There are three main factors. Number one is magnitude of force, and number two is magnitude of position vector, and number three is angle between F and R. Torque is directly related to force and magnitude of position vector, and angle between torque depends on sine ratio of angle between F and R. Finally, look at the cases when torque is maximum and when torque is minimum. So remember, torque will be maximum if angle between force and moment arm, or you can say it as position vector from pivot to the point of application of force, is 90 degree. And in this case, torque will be Rf sine of 90, and sine of 90 is 1. So torque will be maximum and is equal to product of force and moment arm. And when torque is minimum, the torque will be minimum if angle between force and position vector or moment arm is 0 degree or 180 degree. In both of these cases, line of action of force passes through the pivot point, and torque will be Rf sine of 0, and sine of 0 is 0. So torque will be Rf into 0 means 0. Similarly, if consider the case for anti-parallel 180 degree, sine 180 and sine 180 is 0. So torque will be Rf sine 180, which is 0, and torque will be 0. So in this way we have discussed completely all aspects about the torque. Thank you.